For this video, we're going to talk about another way to factor, and that's using the quadratic equation. So I have the quadratic equation written over here to the right. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's the quadratic equation. You can use the quadratic equation when it's in the form of ax squared plus bx plus c. Now you can be missing parts, like you can be missing the b or missing the c, but it needs to be a second degree polynomial in order for this to work. Because you cannot be missing the a, because you can't plug in a 0 here, because you can't divide by 0. So let's start out with an example. This will be a pretty easy example. We're going to do x squared plus 4x minus 12. Okay, so let's start out, if you need to, and we'll do it on this one, we'll go ahead and list out. So our a equals 1, b equals 4, c equals negative 12. So we're going to take all the steps on this one, and in later examples we're not going to take every single step. If you need to, you can list them out. Hopefully you get to the point where you don't have to do that. So what we're going to say is we'll say x equals negative b plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 12. This is all over 2 times 1. So now what we're going to do is we're just going to use our order of operations. So we want to work underneath that radical first. So still x equals and I'm just going to continue working through this. So we'll just 48. We'll skip over these steps in the next examples, but just to start with, so that's going to equal negative 4 plus or minus 64 over 2. We can take the square root of 64, which is going to leave us with 8. So then we can say, now let me point out one thing here, and I'm going to point this out again later. At this point, you may be tempted to cross this out, because you got a 2 here and a 4 here, so we could simplify that and make that a 2 and make that a 1. The problem is, whenever you have a plus or minus, like I said, I'll point this out later, whenever you have a plus or minus, you cannot cross these out. It has to be able to cross out with both of them, because if you remember how to add fractions, you can add the fractions, you get a common denominator. So it's like we're adding these two separate fractions, where a common denominator is 2. Now at this point, since we have it in both, we could simplify it. But what we're going to do is we're just going to work this out the long way. So we're going to take this over here. We're going to say negative 4 plus 8 over 2, and then negative 4 minus 8 over 2. So negative 4 plus 8 gives us 4 over 2 equals 2. Minus gives us negative 12 over 2, which equals negative 6. Now what's different about this and the other ways that we've factored so far is, if you'll remember, we're saying this is all x equals that. So what we have right here is we have x equals 2 and x equals negative 6. So if we were solving for it, so if this problem had said equals 0, and we want to solve for x, and we just solve for x, but if we're just trying to factor it, then what we actually need to do is we need to set both of these, x equals 2, x equals negative 6. Now we want to get them on the same side. So minus 2 plus 6 plus 6, so we get x minus 2, x plus 6. If we fold this back together, we get x times x is x squared plus 6x minus 2x minus 12, x squared plus 4x minus 12. So we can see that that worked out, and we got the same answer. So like I said, if you're factoring it, to solve it, to actually find out what x is, you can just stop here. But if you need to get it into this form, you're going to need to work down a little bit more, but not too much. So let's work another example, and I'm going to show you the reason that the quadratic equation can be so valuable. So on that last one, we got two pretty straightforward answers. We got 2 and negative 6, or x minus 2, x plus 6. But in this one, I'm going to show you the reason that you need to learn the quadratic formula, even though it obviously that last one took a lot longer to do than maybe factor by grouping or the guess and check way. But the reason that you need to know this is because it will always give you an answer to your second degree polynomial, because you can find imaginary numbers and you can find irrational numbers. So with this one, you're never going to guess these numbers doing the guess and check method, or even the factor by grouping is not going to work for this, because your answer is actually going to be a irrational number. So for this one, let's set it up. We're going to say x equals negative b, which b is 7 in this case, plus or minus the square root of b squared minus 4 times a times c all over 2a. So if you want to, go ahead and work this stuff out in the middle. I'm going to show you what it's going to actually end up being. It's going to be x equals negative 7 plus square root of 217 over 4. So we're not going to be able to reduce this any. We can't cross a 4 out with anything. The square root of 217 is an irrational number, so we're not going to reduce that at all. But this is actually your answer right here. That is what x equals. So this one, you're not going to say, you're not going to add it to the other side. This would be one we're actually solving it. But this is going to be a rational number, so that's the reason that this is good, is because you can find the answer regardless, and then you could plug this into your calculator and you could actually get 2 decimal values for it. So let's do another example. On this one, we're going to come up with an imaginary number. So we're going to say 5x squared minus 6x plus 3. So we'll say x equals negative b, so in this case it'll be a positive 6, times the square root of 6 squared minus 4ac all over 2a. So that's going to leave us with 6 plus or minus square root of 24 over 10. Now, one thing to be really careful, like I already said, don't try and cross these out here, because you got a plus or minus. You're not able to cross that out, but we can reduce this right here to where we could cross it out. So what we're going to do is we're going to take this up here. Let's just work just with this negative 24 for a minute, or negative square root of 24. And there'll be a video, if it's not up now, it'll be up eventually, I'm going to do where we actually talk about how to do this in more detail. But just in case you've forgotten or haven't watched it, how you're going to do this is you want to find something that's a perfect square. So like 4, 9, of course 4 is going to work for this one. So we're going to break this thing down. We're going to say 4 times 6 is 24. We're going to say times negative 1. Okay, the square root of negative 1 is I. Square root of 4 is 2. So that leaves us with a 6. So we've just reduced that to 2I root 6. Like I said, eventually, if it's not already up, I'll make a video where I show you how to do that more. But this is just a little reminder of how to do that. So now we got 6 plus or minus 2I root 6. So we're going to reduce this one a lot more, because we got a 10 here and we have these two numbers where we can pull something out of it. We're not able to mess with this because it's under the radical. So we're going to leave that root 6 alone, because that's actually an irrational number. But what we can do is we can go in here, we can make this a 3, we can make this a 1, make that a 5, because I just pulled a 2 out of all of those. I know I've emphasized this a lot, but this is a really common problem. Whenever you have a plus or minus here, or just a single plus or just a single subtraction, it doesn't have to be the plus minus symbol itself, but any addition or subtraction, you cannot just cross that out with one of them. It has to go with both of them. So now we've simplified this to 3 plus I root 6 all over 5. So this is an imaginary number. Whenever you're talking about solving a quadratic or solving a polynomial, you're looking for roots or zeros, and then whenever you get to that point, you hopefully will realize that this imaginary number is not going to be on our graph, but it's still technically a root of the problem, so it's still something good to get to. So like I said, the quadratic formula is a much more difficult way to do these than maybe factor by grouping or just guessing the check method. But it's good because you can find the roots even if it's an imaginary number or if it's an irrational number.